Hello, welcome everyone. Today we are going to complete the indices sheet. This is part 3 and in this lecture we'll be starting from the question 9. So let me start. See this question. It says x equals a to the power of b and y equals b to the power of a. Now you have to express the following in terms of a and b. The questions are given in terms of either x, y or the combination of both, but we have to convert the answer in terms of a and b. X squared over 2. X is what? A to the power of b. So a to the power of b whole squared over 2, or applying the third rule, that is a to the power of m whole to the power of n, that is if the powers are over another power, just multiply them together. It will be a to the power of 2b by 2. Very simple. The next one is exactly like the first part, that is y squared by 2. Y is b to the power of a. So b to the power of a whole squared by 2, and this can be written as b to the power of 2a by 2. X is a to the power of b and y is b to the power of a. That's it. You can't do anything because the rules are dependent on whether the base is same or not. X plus y, a to the power of b plus b to the power of a. Again, we can't do anything, so leave our answer like that. Now look at this question. X is equals to 3 to the power of a, y equals 3 to the power of b. If xy equals 27 and x by y equals 3, then give the values in integers. The first one is find the value of a. That means we have to calculate the values of these powers. And for that, the best thing is we need to substitute. So in place of x and y, we have to substitute their values. So if in place of x, I'll write 3 to the power of a into, in place of y, it's 3 to the power of b, and this is equals to 27. Whenever we have question like this, where we have to calculate the values of power, and something is written in right hand side, so always try to convert it into a prime number. Prime number, that means 27 can be written as 3 into 3 into 3, and in index form, I can write it as 3 to the power of 3. So 3 to the power of a into 3 to the power of b in exponent form, we can write it as 3 to the power of 3. Having the same base, if we multiply two numbers, we need to add the powers. So 3 to the power of a plus b equals 3 to the power of 3. So having the same base, now we can compare their powers. So a plus b is equals to 3. This we got from our first equation. Our second equation is x by y is equals to 3. Similarly, we need to substitute. So x by y is equals to 3, and that can be written as 3 to the power of 1. X is 3 to the power of a, y is 3 to the power of b is equals to 3 to the power of 1. Same base, when you divide, you need to subtract the powers. So 3 to the power of a minus b is equals to 3 to the power of 1. Bases are same, just equate the powers. So a minus b is equals to 1. Now this is your simultaneous equation. You can solve it by elimination method. Already b and b have the same coefficient and in opposite direction or having opposite sign. Add it up. 2a is equals to 3 plus 1, 4. From here a is equals to 2. If a is equals to 2, we need to substitute the value of a in either of the equation. So let me put 2 plus b equals 3 and b equals 1. So let me move on what they are asking exactly. The value of a, we had just calculated value of a as 2. So value of a is 2. Then let me move on to the next one. Value of b, we just calculated value of b, which is 1 right there. So b is equals to 1. Value of x plus y. Value of x plus y. So what I need to do, x was 3 to the power of a and y is 3 to the power of b, and we can't add it, we can't do anything, so just leave it like that. Now, value of 2x squared, x is 3 to the power of a, so 2 times 3 to the power of a whole squared, or that can be written as 2 into 3 to the power of 2a. Either leave it like that, or what you can do, you can write it as 2 into 3 to the power of 2 whole to the power of a. It means the same exactly. Ultimately, a to the power of m whole to the power of n is a to the power of mn. So that means either you will write a to the power of n whole to the power of m or a to the power of m whole to the power of n. Answer is always a to the power of m. So that's why I interchanged it, and it can be written as 2 into 9 to the power of 8. Value of 3y squared by 2. So 3 by 2 as it is. 3 to the power of b whole squared. In place of y, 3 to the power of b whole squared we have to write. We can do similarly 3 to the power of 2 whole to the power of b. We can simply flip it. Or 3 to the power of 2 into 9 to the power of b. That's your final answer. Solve the following. 3 to the power of 2 multiplied by 3 to the power of half over 3 to the power of 3 equals 3 to the power of m. If we are calculating the value of any power, we always have to convert left side and right side in the same base. Unfortunately, all the base numbers are 3 already. Applying the first rule where we are multiplying, we have to add the powers. So 3 to the power of 2 plus half. Over 3 to the power of 3 equals 3 to the power of m. 2 plus 1 by 2 is 5 by 2. 3 to the power of 5 by 2 over 3 to the power of 3 equals 3 to the power of m. Now we need to subtract the powers because we are dividing. 3 to the power of 5 by 2 minus 3 power of m. This can be written as 3 to the power of minus half equals 3 to the power of m, and m is equals to negative half. Now 3 to the power of 2 into 3 to the power of half over 3 to the power of 3 can be written as k root 3, then find the value of k. So we just calculated that was 3 to the power of minus half. And we know fractional power. This can be written as 1 over 3 to the power of 1 by 2. Or this can be written as 1 by root 3 because root is 1 by 2. Cube root is 1 by 3. Now we need to rationalize it because it should be in form of k root 3. Root is in above in numerator. So multiply root 3 and divide by root 3 in order to make the denominator an integer. So root 3 by 3. Or this can be written as 1 by 3 into root 3. Clearly it's in the format of k root 3 where k is 1 by 3. So k is equals to 1 by 3. Simplify the following. 12x squared y multiplied by 6xy cubed over 24x cubed by 6, 9x cubed y to the power of 5. So simple. 12. What I'm doing, I'm just separating out numbers. So 12 into 6, we can do like this. Over 24 into 9. X squared y. I have written this one. Multiplied by xy cubed. Over x cubed y to the power of 6. Into x cubed y to the power of 5. Applying the first rule, if bases are same and we are multiplying them, add the powers. So this can be written as 12 into 6 is 72. X cubed y to the power of 4 over 24 into 9 is 216. Doing the same thing when we are multiplying, add the powers. So x cubed, this will be x to the power of 6, and for y it will become y to the power of 11. Now what we are doing, we are just dividing it. And on dividing, first divide the numbers. Let me simplify it. 1 by 3. X cubed over x to the power of 6 is x to the power of 3 minus 6. Y to the power of 4 over y to the power of 11 is y to the power of 4 minus 11. So answer is 1 by 3 x to the power of negative 3 y to the power of negative 7, or 1 by 3 over x cubed y to the power of 7. That's your final answer. Simply simplify it. 3 to the power of m plus 3 to the power of m plus 1 over 4 into 3 to the power of m plus 3 to the power of. Simply divide numerator and denominator by 3 to the power of m. It will simplify this. So 3 to the power of m over 3 to the power of m plus 3 to the power of m plus 1 over 3 to the power of m. How I got to know that I have to divide with this? Because if in numerator denominator there are exponent, they are indices form, and they are asking you to simplify. So divide both the sides, both the numerator and denominator, by the smallest exponent. Between 3 to the power of m and 3 to the power of m plus 1, 3 to the power of m is the smallest one. That's why I have divided it. 4 into 3 to the power of m over 3 to the power of m plus 3 to the power of m plus 1 over 3 to the power of m. So this can be written as 1. This is, we need to subtract m plus 1 minus m. Cancelling out, this will give you 4 and 3 to the power of m plus 1 by 3 to the power of m. Dividing, having same base, subtract the powers. So m plus 1 minus m is 3 to the power of 1. Answer is 4 over 7 is your final answer. Show that 1 over 1 plus x to the power of a minus b plus 1 by 1 plus x to the power of b minus a is equals to 1. We have to show that left hand side is equals to right hand side. So what we have to do is, we have to take left hand side, the left term, try to solve it, simplify it, and see whether we are getting 1 or not. Definitely we have to get 1, because they are asking you show that this is equals to 1. So we are sure that this whole expression is going to be 1 at the end. Using exponent, the second rule, a to the power of m over a to the power of n is, we subtract the powers. So if we go reverse, x to the power of a minus b is what? X to the power of a over x to the power of b. So we need to replace it with x to the power of a over x to the power of b. 1 plus x to the power of a over x to the power of b plus 1 by 1 plus x to the power of b over x to the power of a. Take the LCM. This will be x to the power of b plus x to the power of a over x to the power of b plus 1 over, taking LCM, x to the power of a plus x to the power of b over x to the power of a. Now we need to flip it. If 1 divided by a fraction, it will go up there. If you're a little confused, I have already made a video on algebraic expressions, solving fractional expressions. You can refer that. So this will become x to the power of b over x to the power of b plus x to the power of a, x to the power of a over x to the power of a plus x to the power of b. Clearly you can see denominator is exactly the same. So add the numbers or the expressions on numerator, x to the power of a plus x to the power of b in denominator, and in numerator it's also x to the power of b plus x to the power of a. This can be written as 1 because they both are same. So on simplifying, we'll get 1. So we have shown that left hand side equals right hand side. Show that 3a whole to the power of a plus b by 3 to the power of b. 3b, this is actually in power, 3 to the power of a whole to the power of a plus b. 3 to the power of b whole b plus c, 3 to the power of c. So this is actually 3 to the power of a over 3 to the power of b whole to the power of a plus b multiplied by 3 to the power of b over 3 to the power of c whole to the power of b plus c into 3 to the power of c over a 3 to the power of a whole to the power of c plus a. This first can be written as, when we divide the exponents, it's 3 to the power of a minus b whole to the power of a plus b into 3 to the power of b minus c whole to the power of b plus c into 3 to the power of c minus a whole to the power of c plus a. a to the power of m whole to the power of n, when there is one power over another power, we multiply it. So 3 to the power of a minus b into a plus b is a squared minus b squared into, when I multiply these two powers, this will give me b squared minus c squared, b squared minus c squared into c minus a into c plus a is c squared minus a squared, so c squared minus a squared. Applying the first rule, where we have the same bases, we are multiplying, we add the powers. So 3 to the power of a squared minus b squared plus b squared minus c squared plus c squared minus a squared. They all cancelled out. C squared plus minus minus a squared plus a squared minus b squared plus b squared. 3 to the power of 0 is 1. So hence we have shown that left hand side is equals to right hand side. So that's it for today. Thank you and stay tuned.